Student, these are the practice questions for organic chemistry, and topic is isomerism. This video is equally important for FSc student, intermediate, A-level students, as well as for intermediate student of all the boards in Pakistan, India, Bangladesh, and also up to the graduation level, because these are the basics of organic chemistry. So the question is, draw the four possible isomers. No, I think I have made a mistake. The question should be, draw the possible isomers of C5H12. So how will you do this? First, you mention that 5 carbon atoms are there. So first you draw 5 carbon atoms almost at the equal distance. So 5 carbon atoms are there. So make it the straight line hydrocarbon. Terminal has CH3, and these all are 2-degree carbon atoms which have 2 carbon atoms on either side. So the remaining 2 valency can be balanced by hydrogen, and it is also terminal, so this is also CH3. So this is one of the isomer. And what should be the name? 1, 2, 3, 4, 5. So it should be N-pentane. Or you just write pentane. Both are correct. Pent because there are 5 carbon atoms, and N because all the carbon-carbon bonds are single. So now you can draw another structure, but you draw only 4 carbon atoms in a chain, and one must be as a branch. So now balance the valency by carbon. So one carbon-carbon bond is there, one carbon-carbon bond is there, and one carbon-carbon bond is there. So the remaining valencies can be satisfied with hydrogen. So there are 3 hydrogen, there are 3 hydrogen, there is only 1 hydrogen. And 2 hydrogen atoms are there because 2 valencies have been satisfied. And this one is CH3. What should be its name? Its common name is isopentane. Isopentane. Iso means if the second last carbon has 2 CH3 groups, then such compounds are called iso. Or you can say second carbon has, in case of hydrocarbon, this is considered the second carbon. So if the second carbon or the second last carbon atom has 2 CH3 groups, then such a compound is known as iso. But there should be no other branch. So total carbon atoms are counted here. But the IPSC name of this compound is, this is the common name. And for IPSC name, select the basic chain. This is the basic chain. Start the numbering from where the group is nearest. So this is 1, 2, 3, 4. So the name of the compound is, IPEC name of the compound is 2-methyl 4 carbon atoms are there in the basic chain. So the parent name is butane. And another possibility for C5H10 draw the chain of 3 carbon atoms and On the central carbon atom, put two more carbon atoms in this way. So a new compound was developed, it was identified, and the name of this compound is Neopentane. Neopentane is the common name, but its IPSC name depends on the groups. I'm sorry, there should be CH3. So numbering can be on either side because on second carbon, two methyl groups are there. So the name of the compound would be, on second carbon, two methyl groups are there. So 2,2-dimethyl 2,2-dimethyl. Okay. 2,2-dimethyl and basic chain containing 3 carbon atoms. So this is propane. Okay. Now see the B part of the question. Okay, now see, the question 1B says, is there any isomer of C5H10 in your answer to question number 1A? Stereoisomer? Is any one of them is a stereoisomer? So remember that for the stereoisomer, there are two types of stereoisomers: geometrical isomers and the optical isomers. So for geometrical isomers, we need either a double bond with a CC double bond with four different groups. For different groups, or you can say with at least two different groups on each olefinic carbon. Olefinic carbon means which has double bond. Or in another way, geometrical isomers can be possible if compound is cyclic. If compound is cyclic and has at least two different groups on each carbon of each of the two adjacent carbon atoms. If we talk about optical isomers, so a chiral carbon is required, which has all the four groups different. So if you see here, the terminal carbon can never be optical chiral carbon or the geometrical center. There is no double bond, there is no cyclic compound. So geometrical isomers are not possible. Okay. First thing is that no geometrical isomer is possible in all of these three because there is no double bond and no one is cyclic. Number two, if you see the optical isomers, it is another kind of stereoisomerism. So there must be a chiral center. But if you see, the terminal carbon can never be chiral. And if you see here, then all of them has at least two hydrogen atoms. So two groups are same. But for chiral atoms, all the four groups must be different. Chiral carbon is that which has all the 4 groups different. But here you can see that all of them has 2 hydrogen atoms. So these cannot be. And this one, these have 3 hydrogen atom, 3 hydrogen atom, 3 hydrogen atom. So 4 different groups are not possible. And for the center one, all the 4 are same. So it does not give stereoisomerism. And if you see here, it looks, but it is not. These 2 carbon atoms cannot be chiral because it has 2 hydrogen atoms, it has 3 hydrogen atoms. But here it has 1 hydrogen here, 1 ethyl group is there. This is all as ethyl, but these 2 are methyl. Now see, I'm drawing it again. We can draw it like this. This is C2H5. This is hydrogen. This is CH3. And this is also CH3. So it is not it does not have chiral center. So our answer is no. None of the isomer is or give stereoisomers. Okay. Now we will see the next question. Now this question is about C4H8. If you observe that this is an alkene, so the first alkene that you can draw here, first draw the 5 carbon atoms and put a double bond, especially at any terminal, and rest of them has single carbon-carbon bond. So another thing that you can do here is draw hydrogen atoms. Either you can draw on above and below, or you can draw in this way that it should be CH2 because 2 valencies have been satisfied. And here 3 have been satisfied, 1, 2, 3. So 1 hydrogen is there. There should be 2 hydrogen and there should be 3 hydrogen atoms. So the name of the compound should be butanene, because double bond is between 1 and 2 position. And another structure that is possible here is butene. How? Again, draw in the same way. And double bond should be in between the second and the third carbon atom. So this is butene, so it becomes CH3. Sorry, second position. So it is butene. And another possibility that we can draw here is its cyclic compound. See, if we draw the cyclic compound, every carbon atom has two valencies free. So this is CH2, 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 CH2. C4H10, 1, 2, 3, 4, 2, 2, 4, 4 into 6 and 2, 8. And the name of this compound is cyclobutane. Cyclobutane because all the carbon-carbon atoms are single. So the prefix N is used here. So these are the three isomers of butene, or you can say that these are the structural isomers of butene. Better to use the word not butene, C4H8, because this is not butene, this is cyclobutane. Okay, so the B part of this question number 2 says that, is there any isomer of C4H8 in your answer to question number 2A? Stereoisomer? Is there any stereoisomer? Think about it. Now, inspect all these three. It cannot have any group on the this cyclic compound. So it can neither be stereoisomer, neither be optical isomer or geometrical isomer. Because for geometrical isomer, two groups must be there. But here all the carbon atoms have hydrogen atoms. So it cannot give geometrical isomer. And there is no chiral carbon. So it does not give any type of stereoisomer. But if we talk about this, yes, it can give stereoisomer because on each carbon, which are olefinic carbon atoms, have two different groups. One is methyl, one is hydrogen. And this one, no. Although it has two different groups. One is ethyl group and one is hydrogen. But here, both of them are hydrogen. So it cannot give neither geometrical isomer nor optical isomer because there is no chiral carbon in this compound as well. But this can give geometrical isomer, not the optical, because there's no chiral carbon. So now we can draw this compound in this way, that CH3, carbon, hydrogen are there. And remember that if there is olefinic carbon, it is sp2 hybrid, so the bond angle is 120 degree. So one of the isomer is that which has both the methyl group on same side and hydrogen on the same side. And another group is where in one of them methyl is on opposite side and hydrogen is also on opposite side. So such a compound where the bulky groups are on the same sides are called cis. So this is cis-2-butene or cis-butene, and these are on opposite side. So the name of this compound is trans-butene. So these are the geometrical isomers of each other. Both have different physical and chemical properties. Chemical properties to a little extent, but physical properties are totally different for each other. Okay, now see in this question, they have said that when water is added to butene, two new organic compounds are produced. Butene. whether this one or this one, water is added. Both of them have very similar chemical and physical properties and cannot be separated by any ordinary separating method. So first, we will see what happens when water is added. So see here, in some specific conditions, this butene is converted into C, water, and the condition is sulfuric acid and mercuric sulfate and heat for some time. So what would be the product? This is the addition reaction. So on one carbon atom where double bond is there, hydrogen goes, and on another carbon, OH is bonded. It can either of these two. So the name of the compound is 1, 2, 3, 4. So on second position, alcohol is there. So it is butane to all, because on second position, alcohol group is there. So this is butane to all. So if it is butane to all, so now inspect that. Does it is an optical isomer, because the hint is given here that they have very similar chemical properties. So two optical isomers mainly have same chemical properties and physical properties, and very similar physical properties. This very similar is also for physical properties. So it cannot be separated by any ordinary separating method. So it also emphasized that these could be enantiomers. And definitely, if we are just adding water, so how can we get two organic compounds? In a way that there are two optical isomers. Now see, if we draw it in a way that one compound show two groups here, you can draw OH here and this C2H5, that is CH2, CH3 here. And on one side there is methyl. So one group is this, one is hydrogen, one is OH, one is ethyl. So hydrogen can be drawn here. And remember that whenever we draw optical isomers, then there should be hedge and wedge structure. So this is the wedge, and this is the hedge structure, hedge and wedge. And similarly, we will draw its mirror image. So we can draw its mirror image. We can make the duplicate, or the word you can copy paste. So draw it again. Okay. So what happens in this drawing? These group will come forward. CH3 must be there. and hydrogen is here. Why on the plan there is CH2OH, CH2CH3, sorry. And you can see that these are the mirror images, but non-superposable. So these are optical isomers, a kind of stereoisomers. It is because the product butane to all has one chiral carbon. So actually two optical isomers are produced. Two optical isomers that are called enantiomers. Remember that optical isomers are not always enantiomers, but in our syllabus only enantiomers are there in A level and intermediate. So actually two optical isomers are produced on this addition reaction. And enantiomers cannot be separated by any ordinary physical method of separation. They can be separated by chiral carbon, chiral column, sorry, chiral columns using chromatography. So actually you have to perform column chromatography with chiral carbon atoms. So one of the enantiomers can be separated while others later on.